You're standing in the mud of the Cretaceous, staring at a predator that should not exist. A small tyrannosaur with a skull built nothing like an adult T-Rex. For nearly 40 years, scientists believed they understood this animal. Just a teenager waiting to become a giant. But then, new fossils appeared, and a tiny bone hidden beneath its throat revealed a terrifying possibility. What if Nanotyrannus was never a young T-Rex at all? That skull emerged from Montana decades ago, barely half a meter long, and strangely delicate for a tyrannosaur. Scientists struggled to explain what they were seeing. After several names and several interpretations, it became Nanotyrannus lancensis, the dwarf tyrant. The skull seemed to cooperate. Its snout was long and low. It carried more teeth than the usual adult T-Rex, and those teeth were relatively narrow. Some bones were reported as fused, suggesting maturity. Together, those traits suggested a separate hunter living beside history's most famous predator. But fossils don't arrive with birth certificates. A young animal can look so different from its adult form that one species becomes two on paper. That possibility produced an elegant counterargument. Maybe Nanotyrannus was simply a teenage T-Rex, faster looking, slimmer, and not yet transformed into a skull-powered battering ram. The idea shaped decades of research, yet it hid a trap. A growth series can look complete when every disputed fossil has already been assigned to one species. Later, a nearly complete skeleton and an overlooked throat bone would test whether that lineup represented growth or an accidental mixture. In 1999, T-Rex expert Thomas Carr stepped in. He took this mysterious Cleveland skull and compared it to other tyrannosaurs we know a lot more about, like Gorgosaurus. The supposed fusion was not what earlier researchers claimed. Many sutures remained open. Its bone surface looked immature. Features once treated as unique could plausibly change with age. The teeth also weakened as evidence. Tooth counts vary. Some tyrannosaurs appear to change counts during growth, and individuals can differ. A juvenile with extra tooth positions wasn't automatically a new species. The simpler explanation gained ground. Narrow youngster first, broad-headed bone crusher later. Step onto a humid riverbank roughly 67 million years ago. You hear insects, water, and vegetation shifting beyond sight. A slim 6-meter tyrannosaur would still be an enormous problem, but if it were a young T-Rex, the danger would eventually become several times heavier, with a skull built for punishing loads. The growth hypothesis didn't make the animal safer, it made its life history extreme. Then came Jane. You're kneeling in that same Montana clay, brushing dirt off a jaw that might finally settle the fight. Discovered in 2001, Jane preserved much of a small tyrannosaur skeleton and a partial skull. At roughly 6.5 meters long, Jane provided the body the isolated Cleveland skull lacked. Jane had numerous teeth, a light frame, and several fused elements. Supporters saw an animal nearing adulthood. Opponents saw a teenage T-Rex with bones maturing at different times. Both interpretations had weaknesses. Fusion is not a universal clock. Different bones can close at different ages, while some remain unfused in large adults. Histology offered a better tool. Thin sections revealed growth marks and developing tissue. A 2020 study concluded Jane was at least 13 and still growing. That supported immaturity, but could not identify the species. Meanwhile, scientists built the dinosaur equivalent of a family album. Several small and medium tyrannosaurs were arranged from youngest to oldest. One Los Angeles specimen became the baby. The Cleveland skull followed. A larger subadult came next. Adult T-Rex anchored the end. Stand over that lineup yourself, skull after skull under museum light. And the transformation feels almost undeniable. Each specimen filling the gap the last one left behind. The snout deepens, teeth thicken, The skull braces for stronger feeding loads. The animal shifts from a long-legged hunter into a multi-ton predator capable of damaging bone. In 2005, after Jane intensified the dispute, researchers gathered in Rockford, Illinois for a Tyrannosaur conference. This was the seduction of the growth series. Every specimen filled a gap. Every difference became a stage. The story clicked. Then a fossil refused to grow up. Inside the dueling dinosaurs block was a remarkably complete small tyrannosaur beside a triceratops. A 2025 Nature study found it was near somatic maturity, roughly 20 years old, yet only about 5.5 meters long and around 700 kilograms. You're standing beside the slab. The predator's bones remain locked in stone, not scattered guesses. Its growth is slowing. Its vertebrae are closing. It is not waiting to become an 8-ton T-Rex. Its anatomy delivers the blow. More teeth, fewer tail vertebrae, different nerve and sinus patterns in the skull, a remnant third finger, and hand bones that can exceed adult T-Rexes. Proportions shift with age, but whole limbs don't shrink outright. The neat lineup had mixed two predators and called the result adolescence. That was the headline reversal, but science needed independent evidence. The original Nanotyrannus remained only a skull. So what if the dueling dinosaurs fossil really is a new species, but the Cleveland skull is still just a teenage T-Rex? The answer came from two slender bones beneath the tongue and throat. Researchers first tested whether these hyoids preserve maturity signals in living and extinct archosaurs. Under a microscope, juvenile bones showed widely spaced growth marks. Mature animals showed tightly packed outer marks, indicating growth had nearly stopped. The Cleveland specimen's hyoid carried that mature pattern. Published in Science in December of 2025, the result independently supported an adult or nearly adult animal, not a small T-Rex awaiting a gigantic growth surge. The unglamorous throat bone had done what decades of arguing over the skull could not. So, is Nanotyrannus real? Based on the strongest evidence available now, yes. The case no longer rests on tooth counts or a narrow snout. It rests on maturity recorded in separate skeletons, features that should not reverse during growth, and two major studies reaching the same conclusion by different routes. That convergence matters. Skull shape can mislead, tooth counts overlap, and bone fusion varies across a skeleton. But when maturity, anatomy, and a near-complete body all point away from Tyrannosaurus at once, the juvenile explanation runs out of exceptions to hide behind. That doesn't mean every label is settled. The 2025 study split the genus into two species, Nanotyrannus lancensis and Nanotyrannus lepheus, which included Jane. Some paleontologists accept that. Others stay cautious, since Jane was still growing, and age can blur real species differences. Even its place on the family tree is unsettled. One analysis put Nanotyrannus outside Tyrannosauridae entirely, farther from T-Rex than its silhouette suggests. Fossil family trees are hypotheses, and missing bones can still move the branches. What changes if this smaller predator shared Hell Creek with T-Rex? First, the ecosystem gets more crowded. Nanotyrannus was no pocket-sized novelty. At 5 to 6 meters, it was a serious large carnivore. Long lower limbs, a lighter skull, and blade-like teeth suggest a toolkit built for agility and prey handling, not the skull-driven power of adult T-Rex. Place yourself in dense vegetation with poor visibility. A heavy footfall might warn you about an adult Rex. The smaller hunter creates a different problem. Less mass, tighter turning, potentially faster acceleration. What happens if you're detected before reaching open ground? We cannot reconstruct the encounter, but biomechanics tells us these predators were not interchangeable. Second, young T-Rex lose their monopoly on the middle predator role. Juvenile Rexes existed, and they were proportionally leaner than adults. But some fossils used to model their running ability, feeding, and growth may belong to Nanotyrannus. Those conclusions must be audited specimen by specimen, not discarded. A 2026 analysis of T-Rex bone histology suggested slower, more prolonged growth than earlier models. possibly stretching toward 40 years in the largest individuals. That complicates one explosive teenage transformation, but it doesn't revive the juvenile Nanotyrannus idea. Mature, small-bodied specimens are still a separate anatomical problem. Feel the ground answered differently to each hunter's stride. One built to crush, one built to sprint, and you start to sense a food web splitting in two beneath your boots. Third, the end Cretaceous predator community was more diverse than the old one-tyrant model implied. Nanotyrannus and T-Rex overlapped near the asteroid impact during the final stretch of non-avian dinosaur history. Their coexistence suggests distinct large predators divided food, habitat, hunting opportunities, or some combination. Which prey each preferred remains uncertain. Coexistence tells us competition was managed somehow. It does not tell us how. You feel floodplain heat pressing through wet air. Somewhere ahead, a triceratops moves through brush. One predator may have overpowered large targets with a massive head. Another may have relied more on mobility and slicing teeth. The frightening part is not choosing which one ruled. It is realizing the ecosystem had room for both. The controversy also exposes how science works. Researchers weren't foolish for calling Nanotyrannus a juvenile. The idea explained open sutures and immature bone, and it fit the sample they had. Then better fossils turned up. New tissues got sampled, and old assumptions finally met a test they could fail. That is the payoff hidden in the growth series. Its smooth sequence persuaded because it turned scattered bones into one animal's lifetime. But once mature Nanotyrannus specimens were recognized, the same sequence became evidence of classification error. The fossils had not changed. The question had. Near the end of the Cretaceous, you would not have watched one tyrant pass through convenient costumes. You would have shared the landscape with at least two distinct tyrannosaur-shaped predators, each dangerous at its scale. Nanotyrannus was not merely T-Rex before the upgrade. It was another solution to the same brutal problem, catching animals that desperately wanted to survive. And that may be the most important correction. T-Rex remains extraordinary, but it was not alone, and its fame made every smaller tyrannosaur look like a supporting character. Nanotyrannus reminds us that evolution does not organize ecosystems around celebrities. Stand at the edge of that vanished floodplain one more time. Two tyrants shared that horizon, not one, and it took a bone the size of a matchstick to prove it. If a throat bone can overturn 40 years of paleontology, imagine what else is still locked in rock nobody's cracked open. If that changed how you see T-Rex, hit like and subscribe. There's a lot more still buried under Hell Creek.